Good afternoon, everyone. My name is Owolabi Adeniran, and I'll be taking us on today's live DevOps session. I am a junior DevOps engineer with Amoye, and I was once I am also an Amoye fellow. I took the DevOps session for the last cohort. So our live session today will just be an overview of what the CI/CD stage is, and um, we are just trying to show what continuous integration and continuous delivery is in simple words. Just trying to make it as basic as possible. So I'll be sharing my screen now for everyone, and if once I start sharing my screen, you can help me confirm if you are seeing it just by saying it on the chat. So can you confirm if you can see my screen? Just
Yes,
drop the message. And
yes, we can see
okay.
it.
All right, thank you. So starting from the beginning, CI/CD. So I just want to start from here just to make it very, very simple in a way. I want us to imagine an analogy where we have four boys in a room. So four boys are trying to stack boxes in a single room, and they are each meant to fill different spaces in the room, but the rooms, like the way they are meant to stack their boxes, intersect with each other. So the boys are, for better connectivity, I'll just stop my video so I'll not be having connection issues. So the boys are meant to fill different spaces in the room, and the spaces that they are meant to fill with the boxes, they intersect with each other. Imagine a scenario where the boys are they are filling the spaces randomly without any verification process. Like boy one just comes to the room and puts his box in where he feels is meant to be his space. Boy two comes and does the same thing. Boy three comes, boy four comes. They do the same thing, and like that, the process goes on. And there's no verification process to check if the boys are actually placing the boxes where they are meant to be. You can see that over time, you realize that the boys have disrupted the order that they were meant to stack in the boxes, and they have overlapped each other's spaces. Because why? They were just filling in the boxes. They were doing what they thought was correct. They finished, they took the box into the room, dropped it where it was meant to be. But they did not confirm that they had actually dropped the box in the way it was meant to drop. Over time, they realize that they have disrupted the flow, and there will be need for the boys to start a process of rearranging. Let's say after they all stack the boxes, when they stack their final boxes, for them to stop the work, they'll now check to review what they have done. They will see that they have disrupted the order of the boxes, and they need to they need to start a process of rearranging, to rearrange each box so that each box will be able to fit the way it is meant to fit in the proper place. That is the way it is in most stuff. So let us imagine another scenario where, as each boy is dropping a box, there is let's just say a verification, or let's just say there's someone in the room that says, okay, this box is not meant to be at 90 degrees, it is meant to be at 45 degrees. And anytime a boy has dropped a box in a position that is not meant to be so, the person would correct the boy immediately, and the boy changes the orientation of the box before bringing in a new box into the room. When something like that is happening, you see that over time, the boys there will not be something like error in the end of the day. That is what we are trying to do with continuous integration. Continuous integration is the process where we want a scenario where each code that is being given to the database, where each changes that is made to the project is it passes through a list of verification processes before it is made to stay as a permanent edit. So Continuous integration is just the process where we want a seamless flow, where there is no what, there's no there's no opportunity for a bad code to stay in place for it to what cause an error later in the future. So a continuous integration development paradigm just make sure that the spaces for error is very, very minimal, because each process and each review that is being made to the bigger project is what always reviewed in its own way to make sure that what there is no error and there is no glitch before it is made to stay permanently. So imagine our second scenario where the boys are what checking the boxes each time they drop it. So by the time each boy drop the last box in that room, there will be no need for what any rearranging. There will be no need for them to what start another work of what fixing the orientation of the boxes. Why? Because they had made sure that from the start the orientation with which the boxes should have been in the room is the correct one. So that is essentially continuous integration in a nutshell. Every contribution that is made by a team is verified and checked for errors immediately, so that in the long run there will be no scenario that occurs where a bad code was added into the project, into the full project, and then a functionality is what disrupted due to a bad code that was not spotted early. So continuous integration just makes everything easy, that in the end the amount of errors that you faces are very, very minimal. It's like minimal to no errors, because everything there is what verified. It has its own testing process that it passes before it is what accepted as a permanent change to the database. And if we go to the next slide, you can see that the beauty of continuous integration and continuous delivery is what is in automation. The imagine those boys in the room now. If there was someone that was there, that was like a very basic scenario. But when we're talking about code, we can't have someone that will always be what fact checking codes that are made or edits that are made to code. So there has to be an automated process that each code passes through that automated process to what to when we pass it through that automated process and it has been shown to what pass the necessary checks that I need to pass before it can be added to the database. So the main beauty of continuous integration and continuous delivery is the automation that we have. That automation is available for people that made edit to code, that everything is fact checked. And there are a lot of tools that are used, industry standard. Some of the major ones are Jenkins. We also have Bitbucket pipelines and Circle CI are some of like the industry standard that are used by companies to to implement their continuous integration workflow, because it is like a way you don't need to have someone that is always checking each code made by each team, because in an organization there will always be different teams working on different parts of a code. So different people that are making different edits to the code, there doesn't have to be someone that is in charge of making those check or making those verifications. One person, there's an automated code that's been created already that does what fact checks each of them automatically. And if anything is found wanting, if any error has been identified in a code that has been made, it immediately notifies that team of the error, that okay, I found an error in this bit of code that I have pushed to the, let's just take it in layman terms, repository per se, that I have pushed a code to the repository and I found an error in that code. So because of that, I won't be the code will not be allowed to stay. So the team that is working on that part of the code is they are immediately able to check their code and make edits to that error, and then reinitialize the process of adding their code, that's making another push to the repository, so that the error that was encountered before has been fixed. And if the new push they make is eventually added to the repository, then you can see that in the long run, they have been able to cover for a future error that could have occurred if that code was not fact checked at that time. So automation tools such as this enable us to create automated processes that checks each and every code, and each automation process can be like can be customized for different teams, can be customized for different codes, but the ideology is the same, that we want a what? An automatic process to what? Verify any push that is being made to the repository. So GitHub Action is another popular tool that is used for continuous integration. I think everybody here, because even to submit your lab, you use GitHub. GitHub is one of the most popular tool for collaboration amongst people now. And GitHub itself as a platform, it has something called GitHub Actions. And I think that was what you guys did for your stage A, if I remember correctly. GitHub Actions that is used to what? Is a method that is also used for CI/CD. GitHub Actions is used to what? Keep track of all edits and push made to a repository, and it immediately notifies the developer of any change that does not pass the required checks. So that's just the same thing. So with GitHub Actions, you have something that once is always active in a way, and there are GitHub Actions that you can customize them to only come up when a particular type of change was made to the repo. You know, we can have things like pull request, we can have push, we can have merge and stuff like that. So you can there are GitHub actions that you can create for each of all of these processes, so that when any of those action is made, the GitHub action will come up and and verify if what it needs to be there is there. So if what is meant to be there is there, like if there is no error that was found, then everything is all good and fine. But when there's an error found, it will immediately notify via email, to send an email to the team or to the person that made the ID that I've performed so and so checks, and this is what I found, and this is wrong. So the next one, I'll just be like trying to showcase GitHub actions in a simple manner, because the next slide. So this is GitHub Actions. So GitHub Actions works with the GitHub repo. So I prepared this just for time, so we won't waste too many time. I prepared this just for us to be able to view what it does. I can show us again on GitHub if time permits. So this was me first creating an empty repository in my GitHub account. I created an empty repository. You see that my initial commit, it had just the README file, and there was nothing in the README. So every GitHub action file is located in a hidden folder of GitHub. It starts with .github/workflows. So every action that you want to implement, that is where they have to be stored for you to be able to, for GitHub to be able to recognize it as an action that it needs to perform. So every action, you create it and it is stored in a folder called .github, and in the .github is called workflows. So I created that also, and you can see that the commit message here is what? Create workflow 1.yaml. So that's create workflow 1.yaml. That's the name of the action. Or no, don't let me say action. Let me say the name of the file that will contain the action that I want to implement. So if you come to the next snap, so this is the content of the YAML file that I created. So this is the content, this is the action. So breaking this down into different the different parts that are there. What's the first thing? The first thing is the name. So this is the name of the action. While the name of the file is called what? Workflow1.yaml. The name of the file does not necessarily entail the what? The name of the action. So the name of the action now will be called what? Sample workflow. That's the first thing. And this is what we call the what? The condition that what makes the action to what? To start. So it is called, if I remember the terminology correctly, it is called, I think it is called the, I fail to remember the terminology, but when you use the on keyword is what allows, it is what enables the action to know that, okay, this is when I want this action to occur. So if this edit is made, and the edit that is made does not belong to this event, exactly, that's the word, it is called event. So I want the event for this action to occur to be called the what? The pull request event. You can also go to GitHub Actions. GitHub Actions has a full guideline for how to start implementing work actions on your own. They also give templates when you go to your GitHub profile, if you go to your GitHub profile, let me see if I can just showcase that. If you go to your GitHub profile, if you click on, there's a tab that is called Actions. I'll show that in a jiffy. There's a tab that is called Actions, and the Actions tab, when you click on the Actions tab, you see different templates for different kind of actions that you can implement. But as I was saying, so the name of this action is the sample workflow action, and the event for which it will occur is called the what? Is the pull request event. So on workflow dispatch tell you that, okay, you dispatch this workflow when you have a what? A pull request event. What type of pull request? Either an open pull request or a reopened pull request. And for every workflow, depending on how low level the action is going to be, it needs the permission for it to perform some tasks, because actions can be made to make edit in a GitHub repository or something. So for every action, you give them permissions that you want it to have. So any permission that you give it, if you want it to have a read or write permission, if you want it to have a read or write permission, you can give it a permission that, okay, I want you to be able to write to this repository, or you can give it a permission that I want you to be able to read content that are in this repository. So for this, my action, it is not going to do anything to the repository, so I'm just giving it a read. Permission. So it has the permission to read the content of that repo. So that's the first thing. And then the next thing is what is the job that the action will perform. So when you specify the name, you specify the event that will make the action occur, and you have given it permission. So you now have to start listing the jobs. What do you mean by jobs? You need to start listing. You can just say, okay, these are the checks that will now start being performed for the action. So once the action has come to life and the action is in process already, then this so and so checks will start occurring. And if all these checks, so every check that is here now has to be passed. So if every check that is here that is passed, then you give it a it will mark it as passed. But if there's a check that fails here, it will immediately notify you that there was a check that failed. So jobs means the checks that are going to. So you can make more than one check. So every indent under the jobs are the checks. So you can have this one. I have just one check to make. So that is the check that I'm making. But you can make numerous checks by just going under the jobs and adding another check depending on the amount of checks that you want to be made. So after specifying the check, for each check, it needs to have a runner. A runner is like a just visualize it as a virtual PC, or like a PC that you have that is on the cloud. That is where you are typing the checks. Let me just use something low level in that way. That's the easiest way to visualize it. So the runner is the platform that the check is going to be made on. So the runner is like the
Yeah, I think he has little network issues. He'll be back soon, so just give him some time. Okay, he's back.
hello.
Yeah, we can hear you. I think we lost you for a few seconds there.
Well, oh, I'm sorry, the
Yeah,
network again. So
no
let me
problem.
just continue.
Okay.
I think I want this question. So can you confirm if my screen is being shared again?
Yes, we can see it.
Hello, can you hear me?
Yeah, yeah, we can hear you and we can also see your screen. We can go on.
Okay, thank you.
Oh, I think we lost him again. Well, let's just give it some time to sort out this network issue. We'll be right back.
Sorry for that. I don't even know what's wrong, but the network should be going fine because I don't have issues like this. But I think that should be the end of it. Can I confirm if you're hearing me?
Yeah, we can hear you clearly. It's fine. You can
All right.
continue.
I think my screen is still on. Okay. So as I was saying, I was on the runner. So the runner is like the platform that we used to what perform the checks, and it's just like, let's say you have a virtual system on air. So everything you specify under the after or anything any check you're specifying will be using the operating system of the runner that you specify to what perform those actions. So I just want to perform just what one check, and the steps. So it's just like you're looking at, let's say you want to make, it's just like question one. So question one has what sub questions, that's A, B, C, and D. So it's basically just like that. So this is job, let's call that job one. And then under that job, we can have different steps. So we can have step A, step B, step C per se. So for this job, I have just one step, which is what the name of the step is just one. And because I just want us to showcase to see what it is. It will echo. Echo is like the command line for what? For printing or for showcasing. They just means that show this to the standard output for people that are into coding for a while. So, but you can see that there's a clause here, and that clause is if. So it's just like me using a condition. So I just want this step underneath this if clause to run if the what? The pull request label has something called first. So for each pull request that you create on GitHub, you can give it a label for the pull request, because when teams are working with each other, you need to be able to what? You can't just make edits. You need to be able to, because there'll be like a central person in control of, there'll be a central person in control of, let's say, the repository. So each team that is making pull requests to add to the main database, you might have to label it. Okay, let's say you label it as one is development, or you label it as this one is what testing. So you have to label each pull request that you're making to the final code base, so they will know what change you're trying to make. So I'm saying that what this pull request, any pull request that you make, that the pull request, the label of the pull request contains first. That means the name of the pull request basically is what? FIRST. That's when this step underneath can be run. So if this check that is here does not pass in the first place, you get, so you want to, this is like a way for you to what? Use conditions. So you don't want to type for, okay, I want to type this one for dev, or I want to type this one for testing, I want to type this one for production. No, you can just use conditions to just make that, okay, just keep all these checks. If it is not for dev, then I don't want to perform all this for a pull request that is labeled as dev. I want to perform this for a test. So that's basically what this condition is doing. And then I now say that what? If this condition here is passed, then run this step here. So I just wanted to print something to the output, and what it is going to print out this action was because the pull request contains first in the label. So this is basically a simple action, a one-step action that will occurs when we have a what? A pull request. And the pull request can be a what? A opened or a reopened pull request. So if I go to the next slide, you can see that I now what? Created a pull request, PR created. I just created a pull request. So I intentionally created the pull request on the GitHub repo to see if the action will come up here. And clicking on this action bar. So the way you can see if your actions have been run is on this action bar. So clicking on this action bars, this is what you see. You see that what? One workflow run. So the action I created as what? As what occurred. And you can see it, sample workflow number 1. And when I come here, what did I name it? I named it what? Sample workflow. So my action, sample workflow action, has what? Been run successfully when this what? Pull request was created. So if you click on the workflow, you'll be able to see details about it. And you can see that this is a different picture compared to this one. So when I checked the details on this action, so when I checked the details, you see that it says that there's only one job there. That is only job, which is what we specified here, only job. And then this job was skipped. You get, so that is what's telling you that what the reason why this only job, which is the first check and the only check that is there, the reason why it was skipped is why? Because this condition did not pass. The pull request did not have a label that contains what's called first. So this job was what? It was skipped. Why? Because the condition of if did not pass. So I now I added the label called first to my pull request. So that pull request that I created, I added a label called first. And I will still showcase all of this using GitHub. I just want us to see the full, if there's enough time. After my slide, I'll still showcase, try to do this again. So now I added the pull request, the label first to the pull request. So after adding the label first, I then what? Close the pull request and reopen it again. So after reopening the pull request and coming back to the actions, you see that another actions was created. You see that now the only job that was saying skipped before in the previous one, the only job that was saying skipped in the previous one, now it was completed successfully. Why? Because I had what? Added a label called first to my pull request. So, and if you can see it, it's setting up the job. You see the runner version operating system and all. So that is just it, what setting up the computer. And then since that check was passed, what does it do? It goes what? It echoes, you see, it is running what? Echo this action. I just told you to what? Print out this action runs because the pull request contains blah blah. And you can see the last line here where I am on. The last line is just printing out that because what the action has what successfully completed what it was meant to do. So this is just like a very simple illustration of what this can do. It is very, very useful and very, very functional. It can be applied to many different things. You can use it to make various kind of checks to the edit you are making, to the changes you are making to the for your assignment. I think the assignment is basically the follow-up labs for this cohort also is basically based on how good you are with GitHub Actions. So this is just me trying to like introduce you to what you face in your follow-up lab. So you are basically just going to be showing how you can use the GitHub Actions and how well you can work with them. So that is what GitHub Actions does in a nutshell. So for this first check here that was skipped, I got a mail on my email that this so and so check was skipped. For every check that is made, but the mail actually only focuses on when a check is what? When a check is not when a check is not what? Not passed. So when a check is not passed, that is when you are sent a mail that tells you that this check was not passed, and then you might have to what? Start it. You might have to what? Make changes to your code, and then reinitialize your pull request so that you have a continuous code that is what? Always correct, if I can use that terminology. So the next slide, that's everything I've been talking about as bordered on continuous integration. That's always making what? Edits that is what? Added to the code database, and the edit that is being made to the code database is what? Is standard and is error free. So we now have the other part of CI/CD, which is what? Continuous delivery. So continuous delivery, or sometimes you can use continuous deployment. So continuous delivery is just like the continuation. So let me just use this analogy. Remember analogy of the boys. So imagine that as the boys were stacking the boxes, there is a back door. So let's say there's a room. They are stacking the room has two doors. So they are stacking the boxes from the front door. Now there's a second door for what? People that are going to what? Come and take the boxes out. Let's say after each stack contains 4 boxes, then the back door will open. People will come out to what? Take 2 of the 4 boxes there, and then the boys keep stacking their own. You get? So in this analogy, if we go back to scenario 1, that the boys did not stack they did not stack the box in the correct way, there will be a time where the back door will not be able to function. Why? Because the boys now have to what? Start the whole process of rearranging their boxes before the people that are using the back door can come in to take out the boxes, because they have not what? They have not been making sure that the boxes were correct right on time. But if the boys, like I highlighted here, if the boys are stacking the boxes in the correct way, then the back door will always be what? Active. There will be no time where the back door will not be able to
Amanda, I think we lost your connection again. Okay, let's just wait for you to set up back again, then continue.
Let's continue sharing my screen. Hello, can you hear me? Can you confirm if my screen is on so I can continue?
Yes, we can hear you. Continue your screen.
Okay. Thank you. So as I was saying, so if the boys are stacking the boxes, if the boys have been stacking the boxes in the correct way that it should be, then there's no time where there will be a downtime for the backdoor, that the backdoor will not be active, because what changes has to be made to the front door, if you get what I'm trying to say. So we have continuous delivery that what enables it gives us the full power of CI/CD. So after we make sure that every edit and every changes that is being made um to the final code base is what error free, then we make every change what's available to the end user at every point in time. So there's no time that, because we want to implement a new change, there will not be a downtime due to what errors that was occurring when we were making those changes. So that's basically the full process of CI/CD, where we are making edit and changes to our full database, and this edit and change that is being made available immediately to the end users to use. And when it's being made available for them to use, it is error free also. We have some important features of CD. They are not features per se, they are ways in which, let me use a better term, that ways in which CD can be implemented exactly. So these are most of them. We have release pipeline, canary releases, release gates, microservices rather than monolith, and blue-green deployment. So coming on canary releases. So canary releases is just like, it's actually originates from a time back in the days when coal mining was one of the in thing. So there were some people that were called canaries then. The essence of canaries were to what? They go into the mine first before the miners. So they act as the, how do we call them now? Let me use this term, scapegoat, exactly. So they act as the scapegoat. So if the mine contains poisonous gas, it is the canary that will die, or it is the canary that will what? Inhale the poisonous gas to come out and tell the miners that what? This mine contains what? Poisonous gas. So the canaries then were like the scapegoats that will make sure that what? Any mine that the miners want to go into is what? Is suitable for mining. So that is basically what we are doing for canary releases. So for canary releases, they can have, like, let's say if it is an in company thing, for example, now we can have a set of people in the company that, let's say, they like testing out new products. As in a company, we'll know the characteristics and trait of each personnel. So we can have like a set of four, depending on how large they are, how large the company is, that can just what? They'll be the canaries. Let's just use that term. So anytime a new change has been made, anytime the CI stage has been passed and we're moving to the CD stage, they will first be the ones to what? Receive the new changes and the new development that has been made to the code base. So based on the feedback gotten by the canary, that's when we now what? Make a full release to what? To the rest of the end users. Or based on, if they say, okay, based on their reviews, the canaries say that this edit is not something that they feel should be made. And then we can just what? Go back to our code base and just what? Version it back to the previous version that it was. And since we have not what? Deployed, we have not delivered the new edit to the rest of the end users will still be getting what? The maximum service that they are getting without any downtime, or without any need to pause the deployment for a while just to be able to go back to the previous version. So that's how canary releases work. There are people that act as canaries to what? To help us check and maintain that what? The edits that we're making are going to be valid before we then give it to the full database. Another popular implementation is the blue-green deployment. So with blue-green deployment, we can have two replica environments. Let me just put it that way. Two replica environments that can be accessed by the public. But the way it works is that after the CI stage has been passed, before moving to continuous deployment, the CI stage must have been passed. So after the CI stage has been passed, where we have successfully integrated the code to the code base, the deployment goes to what? One of the two environments at that point in time. So when we have two environments and the deployment goes to one environment, is that environment that the deployment has gone to, that is where we will channel to the end users to access. So when we push those changes, when we deploy those changes to the environment and the end users are accessing it, if something occurs, let's say, for example, that the end users now say they don't like the changes that have been made, for example, or they still need some edits, or they prefer the older version or something like that, we can just what automatically change the endpoints that we are serving to the end users to the what the second replica development that the deployment was not made to. So at that point in time, we're able to immediately switch back to what we had before we made that that deployment edit. We're able to immediately switch back and the end users have what they want. And then for the place that we made the deployment, we're able to work on it to either change it and make it better, or to also take it back to the previous version and then start a new process of edit or leave it at the point where it is. But we can also have the case where after serving to the end users are okay with it, and it is a it is a good edit that they all want and they all embrace. So we now go back to the CI stage and make that same deployment to the other stage. So let's say we have the blue and green. So we have deployed to green and people are accepting it. People like the changes that have been made. Then we go back to the and make deployment also to blue. So we now have an updated replica of the two environments. So the blue environment and the green environment at every point in time have to be a replica of each other. So what we just do to the end user is just we can just change where we are routing the end users to. So after making the changes, we route the end users to the environment that has the changes. If it happens that the changes does not go well, does not sit down with the end user, we take we just route them back to the previous one, and then we're able to work on that development. So those are some of the ways in which continuous deployment is made. Is also very popular Another one that is also very popular is microservices and instead of monolith. So monolith is just like a term, something huge, something that is large. So monolith has always been the way that things were implemented in the past. So with monolith, every code is in the same place. Let's say, for example, now we want to write a code to do something. Every part of that code is all in one database. That is how monolith works. So after you are done with everything bundled up together, that is when you can release it to the public. But with microservices has made a way for us to be able to Microservices has made a way for us to be able to We'll now instead of having everything as a single code base, we'll now start implementing different functions one by one. We'll start implementing different functions little by little. So after implementing each function, I know that each function works the way it should. Then we'll now start linking up. We'll use services to link up each function to make sure that they work the way they should. And that will now be the final deployment that we'll make. So microservices make it very easy to be able to to be able to implement continuous integration and continuous deployment. Why? Because with microservices, you can customize integration checks for each of those services. You can customize the way each service will be deployed, that will be able to work compatibility with the previous one. But with monolith, any change that you made to one code base, you have to test the full code base again. You have to make sure that each of the food cables are working in tandem with each other. So with monolith, it's very hard to be able to implement continuous integration and continuous development. So for organizations or for firms or for any project that is going to employ CI/CD methodology, it has to contain it will be better if it is orchestrated as as microservices rather than a monolith application. So that is the end of my slide, and that's just like a very layman level, just like using layman terms to be able to visualize and understand what continuous integration and continuous deployment is, and why and how it is useful in production environments. So that's all for my slides. that's all for my slide. So let me just stop sharing my screen and see. So does anyone have any question? You can just paste it on the chat. Or if you do not really understand my explanation on the actions, if I can just show it to you quickly on GitHub, how it works on GitHub. You can just respond on the chat if there's any question or if there's any part that I said that you don't really understand. I don't think I can see anything yet. So can all these features of CI/CD be deployed at the same time? When you mean all these features of CI/CD, are you oh, okay, I get. Yeah, are referring to my slide saying the features that I listed? You can CI/CD, yes, but is basically one of them that is being used. Basically, it's only one of the processes that is maintained for what as the continuous deployment what process. So when you have decided that this is the one that this is the methodology that we're going to be using for the continuous deployment, and that is just that basically that one that will be used for the long run. When I shared my screen, I also showed you something called microservices. So for microservices now, microservices is a feature that you can integrate with any type of continuous deployment methodology you want to implement, because microservices is not really like a feature of CI/CD only. It's like a methodology of implementation of expert solutions in general. So you can decide that okay, you want to use both A/B testing, you want to use both blue-green deployment in what in combination with canaries, for example. It is quite possible because it will also be easier for you, because canary CI/CD now doesn't just work with the with the end users per se. You also have like another form of testing. So if you use blue-green deployment in combination with canaries, it's something that is very possible. So, but it is not advisable to just to have like numerous methodologies. It's just like one methodology, two methodology that work hand in hand is okay. And with that, you can complete your CI/CD process. I don't know if that is enough for you. I really can't pronounce your name. I'm sorry. So I'll prefer not to spoil it. All right. Thank you very much. So I don't know if there's any other question. I don't even think if there are people on YouTube that have questions. So
In the absence of no further question, I guess they actually understood what you explained. That was a nice presentation. And Daniel.
thank you.
Okay, I guess from here on, we'll call it today. That was a wonderful piece, Adriana. Thank you for that wonderful session. Like I said, if you don't fully grasp what he said, of course, there are other resources available for you to grasp to understand better. So thank you very much for joining us on this DevOps session. Um,